Hey you guys, remember we're working inside of our ratio booklet, our yellow booklet. If you're at home, remember you need to print it out. If not, you should have it on you, so I don't think anyone's going to be printing them out. Today we're going to be talking about rates and unit rates. So we had a fun little experiment that we got to do in class today. I'm sorry if you missed it, but we had two students stand up at the front and we had them challenge each other. So we had student A and we wanted to see how many jumping jacks could they do in 15 seconds. And our student A did, how much she do? 27 jumping jacks. So I'll just tell you it's a girl, so girl, boy, how about that? I'll give you something. So we had our girl who did 27 jumping jacks in 15 seconds. I'm all over the place. Alrighty, and then we had our boy come up and he had 20 seconds to do the jumping jacks. Well, he got to do 33 jumping jacks. So it was pretty fun watching them do that. The question is this: who won? Who won? We had 27 jumping jacks and 33 jumping jacks. Well, we had a big argument about that. But then I asked, is this a fair competition? Why or why not? And of course, everyone said, well, he got more time to do jumping jacks. And so that's right. So up here, I'm going to rewrite it. So student A had 27 jumping jacks. Student B had 33 jumping jacks. Now, this is where we had to see, how could we make this fair? How could we make this fair? Well, could we figure out how many jumping jacks that each student could do in just 1 second? And that would be fair. And so that's exactly what we did. We had to find out how many jumping jacks can each student do in 1 second. And this is how you would do it. You would divide the number of jumping jacks by the number of seconds. So that's what we did. We grabbed 27 and we divided it by 15. I'm going to just go ahead and give you the answer. It's 1.8. And then we took our 33 jumping jacks and divided it by 20. And that gave us 1.65. So here it says jumping jacks per second. Remember that word per means for each or for one. So for jumping jacks per second was 1.8. And the jumping jacks per 1 second for student B was 1.65. So who really won? Exactly. Student A actually won because she was able to do jumping jacks faster. She did 0.8 faster and he did 0.6 slower. So we're really going to talk about write each rate in the form of a fraction. Be sure to label the quantities. This is unit rate. When you find how much it is for just one. So if you're looking at student A, it would be 27 jumping jacks per 1 second. This is a unit rate. We compared it to 1. What do you think for student B the unit rate would look like? Oh no, oh no, oh no, Miss Meyer. I love how I just did the math and then I decided to write down the wrong thing. Rewind. It is not 27 jumping jacks per second. That's impossible. It is 1.8 jumping jacks per 1 second. And for student B, it would be 1.65 jumping jacks per 1 second. So this is a unit rate. These two are unit rates because we found how much it would be for just one. Now, go ahead and take a look at your ratio booklet. We're going to be taking our notes in here. So it tells you this is what a unit rate is. A ratio that compares two quantities with different measures. Different measures is called a unit, or excuse me, is called a rate. So we were comparing jumping jacks in seconds, right? Because the quantities are measured differently, there can be no total. There's no total here. And this is where we learn what a unit rate is. A unit rate is a multiplicative comparison where either quantity has a value of 1. We broke it down to where we figured out how much jumping jacks they could do in just 1 second. Now we're going to practice writing the unit rates as a ratio in the form of a fraction, but it's super important that you label your quantity. So let's look at the first box. It says the car travels 30 miles per hour, which means for 1 hour, for each hour. So it would look like this, 30 miles for 1 hour. Let's try number 2. There are 820 birds per square mile. What are the two quantities that we're comparing? Birds and square miles. So it would be 820 birds for 1 square mile. Okay. And the last thing says the fruit costs $2.50 per pound, which means $2.50 for 1 pound. And this is the way you abbreviate pound, LB, which stands for libra in Spanish. So these are all unit rates. Now we're going to actually take an example. We're going to break down the problem completely. So it's at the bottom where it says daisies. So remember, if I ever go too fast, you can just fill out the problems, okay? Or I'm sorry, pause and rewind. Here's our problem. It says Daisy's electric scooter travels 20 miles in 2 hours. 20 miles in 2 hours. So let's go ahead and write that down. 20 miles. Where would the 20 go in this table? Well, I'm sorry. If y'all don't mind, I'm going to pause what I just said, and I want to actually complete this side first, where it says the wording. So the number of miles, miles is 20, is blank the number of hours. Hours is 2 in this scenario. Remember, what did I say at the end? Write your fraction. Your fraction here would be 20 over 2. Can you simplify this? Absolutely. Divide by 2. What are you going to get? 10 over 1. So the number of miles is really 10 times the number of hours. Now let's flip it around. The number of hours, 2, is blank the number of miles, 20. Create your fraction, 2 over 20. If I simplify this again, now I'm going to have 1/10. And that is what you write down, 1/10. All right. Now I want to go ahead and fill out my table. I know one at least, and it's 2. Well, actually, we know multiple. But what's the very first thing? 2 hours, 20 miles. Let's go ahead and fill out the rest of this. If I skip count, 2, 4, 6, skip count by the top, 20, 40, 60. We've broken it down. Now what would the ratio be below? Ratio, miles, miles is 20, 2 hours, 2. Remember, write your fraction. We know it's 20 over 2, which we already solved all the way over there, which is 10 over 1. 10, 2, 1. Okay. And now that we've done that, you got to write an equation. You're going to write an equation to determine the number of miles. Okay? So this is how we solve. How did we do this? What did we do to get M? How do we get M? If I'm starting with hours, how do I go from hours to miles? How do I get from 2, 20? We multiply by 10. That's exactly what you're going to do. You're going to grab your age and you're going to multiply it by 10. And that would be 10 miles per hour. Remember that, 10 to 1. If we're comparing it over here, we've got the ratio of hours. Hours is 2 to 20 miles. And we know that is 1 to 10. Well, how would you solve for H? If I'm starting, I'm going to change my color to blue so that you can see it. If I'm starting at 40, how do I go from 40 to 4? Some of you are like, oh, miss, divide by 10. Absolutely. But remember I said they're kind of mean to you when they give you the equations? They know that you want to say m divided by 10. But they won't show it to you like that. They're always going to do that keep, change, flip. So we're going to keep our m, change that division to a multiplication, and if I flip 10 over 1, it's really going to be 1/10. Y'all remember seeing that? It was 1/10 m, or just 1/10 hour per minute, or excuse me, per mile. So that was a lot of work. I know it's a lot right now, but you're doing great, I promise. Okay. So now let's go ahead and look at our bottom paper, the next page in our ratio book. Okay, now I'm going to teach you a shortcut. I love my shortcuts, y'all know that. All right, so here it says, which rate best represents each relationship? So you want to find the unit rate. Remember how much it is for just one. But I'm going to show you how you can narrow this down to like just 2 answer choices. So here it says, Kevin earned $500 for 40-hour work week. This is my trick. Which one has more, the money or hours? Money, which means it has to be more money in the answers. So anywhere in the answers, the money has to be more. I'm going to go jump to A. Is the money more than the hour? Remember, per means for 1. So is the money more than the hour? Yes, that looks good. B, is the money, where's the money? 1. Is the money more than the hour? No, it's not. So that one's wrong. It will be wrong. Let's look at this one. C, is the money more than the hour? Yes. And last one, is the money per dollar, $1, is the money more than the hours? No. So now I've narrowed it down to 2 answer choices, A and C. But only one of these makes sense. Go back and read the question. It says Kevin earned $500 for 40 hours of work. Now look at C. Kevin earns the same amount, $500 for 1 hour of work. That's impossible, right? You're like, it just said for 40 hours he makes 500. So now you can knock off C, and you know the answer is A. Why don't you try the next 2 and check with me? Okay, let's see if you got this. I hope you used my trick. Let me read. Mr. Conlon bought 1/2 pound, so 1/2 pound of bluebonnet seeds and paid $1.75. Which one has more? The money has more. So I'm going to go to answer choices and see which one has more. The money has to have more. Per dollar, 1/2. Okay, it's more. Here, dollar. Money is more than the pounds? No, it's not. Is the money more than the pounds? Yes. Oh, I love how I said the first one was right when 1/2 is that. Wrong. B. Is the money more than the pound? Yes. So now I've narrowed it down to C and D. Now, which one actually makes sense? If you go back and read, it said for $1.75, you could get 1/2 pound of bluebonnets. Now it's telling you the same exact amount, $1.75 for 1 whole pound. That's wrong. You know it is C. Okay, a car travels 330 miles on 15 gallons of gas. So we know that miles is more. A, 33 gallons to gallons. We're not even comparing that. Definitely out. So we know miles has to be more. 22 gallons for 1 mile. The miles is not more. Out of here. 15 gallons per mile. Miles, again, it's not more. In here, 22 miles for 1 gallon. This is our answer. So you see how easy my trick can be if you use it. It's very, very helpful. So I want you to go ahead and use your notes to work out on these problems. So you've got a problem solving with rates. You're going to work on these. Please make sure that you actually use what I was talking about. Use that shortcut. Use that hint. I'm going to do problem number 3 with you. I'm going to just show you this. I think it was 3 or 4. I wanted to use problem number 4 with you. So number 4, it says 1/3, I always write the fraction on top, 1/3 pound of pecans costs $2.75. What is the cost per pound? So how much would it cost for 1 pound of pecans? Okay, so if you know it's 1/3, 1/3 pound is 275. So you know you're going to have to divide, right? But do we ever divide? Do we ever take 275 and divide it by 1/3? No, remember what I said. Keep it, change it, flip it. So I'm going to keep 2.75 and really multiply it by 3. Because if I flip that, I'm going to get the reciprocal of 3. So now you can do 2.75 times 3. 15, 22, 8. $8.25 for 1 pecan, or 1 pound of pecan. So which one says it correctly? 8.25 pounds for $1? No. 1/4 pound per dollar? No. It said $8.25 for 1 pound. So make sure that you remember that keep, change, flip. Alrighty, I'm leaving you all by yourself now. So if you have any questions, remember to ask me when you get back to class. Have a good day.